All right, so we're recording now. All right, so tonight we're going to look at geometric series and geometric sequences. The biggest difference between a geometric sequence and an arithmetic sequence is a geometric sequence is exponential. It's the power is growing, so you're multiplying terms instead of adding terms. So they tend to get large pretty quickly. The first couple are going to be pretty simple. We're just going to go through some basic terms, and we'll start working with the equations, and then we'll do summations at the end. So first three terms of a geometric series is 2, -8, and 32. So now, unlike in the arithmetic sequence when we're looking for an addition between each one, this one we're looking at what we're going to multiply each one by. So in this case, 2 to -8, I'm multiplying by -4. So let's see if I go -8 to 32 multiplied by -4 also works. So I'm multiplying by -4. So 32 times -4 is 128 negative. And then I do -128 times -4, which I'm not doing in my head. Is 512. So we have -128 and then positive 512. Just make sure you're doing your signs correctly too and stuff as they switch back and forth. Next one's looking at whether it is arithmetic, geometric, or neither. So we want to look at the difference between them. You can tell pretty quickly if it's going to be arithmetic because they tend to go up a little bit slower and it's the same difference between each one. So like this one from 256 to 64 and 64 to 16, that's not going to be arithmetic. The difference isn't the same between those two. The question that we have to figure out is it multiplied or divided by the same thing each time? So in this case, if I do 265 or 256 divided by 4, I would get 64. 64 divided by 4 gives me 16. 16 divided by 4 gives me 4. So that one's going to be geometric because it's divided by 4. The next one, I'm going 8 to 12, 12 to 16. So that looks like it's adding 4. So this one's going to be an arithmetic sequence. The next one, 16 to 4, divide by 4, 4 to 1, divide by 4, 1 to 4 is multiplied by 4. Since I changed my sequence or changed the pattern, it is going to be neither in this case. Because I was multiplying or dividing by 4 and then I started multiplying by 4. And you're not always going to have one of each. I've seen it where all three are geometric. I've seen it where all three are arithmetic in the sequence. So don't lull it into say, well, they're all the same. Something must be wrong. That's not necessarily true. All right, the next one, we have to determine if it's geometric or not. So is it multiplied or divided by the same thing? And then what's the ratio? So now we're going to start looking at making that equation. In an arithmetic sequence, we were looking for the rate or the common difference, and that was basically my slope. So in this case, I'm looking for what that ratio is or that multiplication is. So the first one, I'm going 20 to 16, 16 to 12. It looks like I'm minusing 4 from that one each time, so that's not geometric. The next one, 500 to 100, divided by 5, 100 to 220, divided by 5, 20 to 4, divided by 5. So that's geometric. And then my ratio is 1/5. That's how we show division by 5. The next one, -4 to -20. it's multiplied by 5, negative 20 to negative 100, multiplied by 5, negative 100 to negative 500, also multiplied by 5. So this is geometric, and my ratio is 5. Just because all the signs are negative doesn't make my ratio negative. In this case, multiplying by a positive 5 keeps the sign the same. If I multiply by a negative 5, the numbers would be the same, but the signs would change. So, right. Any questions on that one? I'm going to start getting into the equations next. So, even though it's asking for the 11th term, and technically we could sit there and do it all out to find the 11th term, I like being able to, when doing this, to just come up with the equation. So my equation for a geometric series is a1 r to the n minus 1. So it's my initial value, and then that's my ratio. So those are the two pieces of information that I need to make my equation. So for this one, an, my initial value is 4, and my ratio, this one's going up by 2. So it's 2 to the n minus 1. And then we want the 11th term. So go to my calculator. These are ones that you're not going to be necessarily be able to do. Like the addition and subtraction ones for the arithmetic ones are pretty easy to do in your head. These are going to get large pretty quick, so it's just as easy to use a calculator. 2 or 4 times 2 raised to the 11 minus 1, which is 10. So the answer for this one is 4,096. So key is come up with this, the formula for it, and then just plug it into the calculator. Next one, same basic concept. This one, they just don't give you the sequence. They give you what the ratio is and the first term is. So a to the n is my first term is 3 over 2, and then it's n minus 1. And we want the 7th term, so it's a7 is 3 minus 2 to the 7 minus 1. Again, go to my calculator. So it's 3 times 3 over 2 to the 6th power. Since it's a fraction, you do have to put it in parentheses. Now, notice I get a decimal for this one. They don't want a decimal. They're going to want it as a fraction. So we're going to use Desmos. So I'm going to do 3 6 powered. And then we just hit that little fraction button, and I get it as a fraction. I'm sorry. Believe it or not, the code is the exact same every single class. So you could have gone to any link. So the answer for this one's going to be 2187 over 64. It's okay. As soon as you told me, I fixed it. So Just took a second for the internet to catch up. So when you're dealing with fractions, I would definitely use the Desmos instead of the Alex calculator. It's just going to give you a fractional answer, which is what they're going to look for. They're not going to look for that decimal answer. And you can tell they're not looking for the decimal answer because they don't say anything about rounding. So all right, so the next one, it says for a given geometric series, so they're giving me basically 2 points, and then we want to figure out my answer. So what we're going to do in this one is I need to find my ratio. So I'm going to set up this equation. So remember, the equation is an a1 r to the n minus 1. I can technically make this a any number I want. So like I can say an and a 11 and then do r to the n minus 11. So the key is these two numbers right here are the same. So notice how there's a 1 there and the 1 there. So whatever number is there, as long as it's minused off the n, it's going to give me the answer that I'm looking for. That's going to help me because that allows me not to have to worry about getting my initial number when I'm doing this problem. So when I'm writing the equation down for this one, my first term, so I have the 11th term is equal to 11 over 16. So I'm going to do A14 equals A11 r to the n minus 11. So let's fill in all the information I know. So A14 is negative 44. A11 is 11 over 16. I don't know r, and then I have 14 minus 11 because that's n minus the 11. So the first thing I'm going to do is I'm going to multiply over the 16 over 11. So I get negative 44 times 16 over 11 equals r to the third. And then I'm going to do the third root of that. So again, this is let's try the Alex calculator, see if it comes out to be a whole number. This one might. So we're going to do the third root, which I can't do. So I'm going to use the negative. I will use the 1/3 power. And then we're going to raise that to the 1/3 power. And we get negative 4. So my r in this case is negative 4. So now we're looking for the 17th term. So I can use any of the numbers I really want in this case. I could use the 14 one or the 11 one. I'm going to use the 14 one because it's a whole number. So do A17 is negative 44 r to the 17 minus 14. No, not r. We know what r is. R is negative 4. So I'm going to do negative 44 times negative 4, and we're raising it to the third power. And I get 28/16. So one of the nice things about this one is because of that, knowing how I can change that 1, I can technically use any value I want. So it saves you some extra steps when you're going through and doing it. But no matter what happens, you still have to find that ratio. I'm going to do one more of these before I move on to the next few topics. All right, so this one, So we're going to do a to the 10th is a to the 5th, r 10 minus 5. So a to the 10th term is 85. The 5th term is 17 over 625. I don't know r, and it's to the 5th power. So I have the 5th root. So I have 85 times 625 over 17, all raised, all to the 1/5 power equals r. So we have 85 times 625 divided by 17 raised to the 1/5. So we get r equals 5. So now my new equation, if we're looking for the 12th term, so I'm going to do, I'll use the 10th term. So it's a to the 12th is a 10 r to the n minus, or I always erase this too much. 12 minus 10. So a12 I don't know. A10 I do, it's 85. R I know is 5, and it's raised to the 2nd power. So it's in essence 85 times 25. Which is 2125. So find the ratio, plug it back into the equation, and then use that equation to find the next point. All right. Next step is it's a combination of the arithmetic and geometric. They just want looking at the sequence, tell me what type it is, and then come up with the formula for it. Remember my two sequences. So I have a to the n equals a to the 1 plus, I always use n minus 1. And then a to the n equals a to the 1 r to the n minus 1. So those are my two formulas that I'm going to use. So the first one, it's going up by 7. So it's an arithmetic. So I've got my first term is 3 plus 7 times n minus 1. The next one is multiplied by 3 multiplied by 3. So it's geometric. So my first term is 7. Then it's 3 to the n minus 1 power. All right, let's do one more of those. So this first one, 3, this is multiplying by 5. So it's geometric. And again, it's the first term, so it's 3. And then 5 raised to the n minus 1 power. This one looks like we're adding 5 to it. So it's arithmetic. And it's going to be 4 plus 5 times n minus 1. And it doesn't always have to be one of each. So again, don't automatically assume that when you're doing it. All right. Last two. So I'm just going to do this so you can write down the formula. So just like when we're looking at the sum of a algebra or a arithmetic sequence, there's a formula. That's the formula for the sum of the geometric series. So we've got Sn equals a1, 1 minus r to the n over 1 minus r. So again, the pieces that I'm going to need to know are my initial term and my ratio and how many terms we have. The one benefit of the geometric sequence or series that we have is the exponents. The exponents are typically going to tell me what how many parts that went out. So if you remember when we did the arithmetic one on Monday, I also had to figure out how many terms there was in one of the problems because it was just adding it. So I had to figure out how many times I added it to get that final term. In this situation, I don't have to worry about that because it's going to give it to me in the actual information. So I'm actually going to show you a nice little trick using Desmos. Redo. So one of the nice things about Desmos is you can type in equations. So we're going to type in A1, and then we're going to do 1 minus, division, 1 minus R to the N over 1 minus R. Now, we're going to do A1 equals R equals and N equals. So what we're going to do is basically all I have to do is plug in those numbers. So when you're doing multiples of these problems, like these problems, you're going to basically have to do it at least 6 times, as long as you don't make any mistakes. So it kind of pays to have that there. So the first one, so I've got my first term is 1/3. Actually, my first term is not 1/3. My A1 is 1, because that's the number that's in front of the parentheses. My ratio is 1/3. And my number of terms is going to be 5. Actually, it's 6. So when we're looking at this sequence right here, actually, I'm going to take what I just said back because this one's actually not necessarily the same. So when you're looking at this one up here, let me actually look at one thing. So this one is a to the n. If I want to get that, so this is my first term right here. Remember, my first term is the first one. So if I had a1, that's going to be, if my ratio is 1/3, that's going to be 1 minus 1, which actually is going to give me 1 as my first term. I want my first term to be 1/3. So I actually have to have 1/3 out in front and 1/3 inside. So my first term for this one actually is 1/3. Also 1/3. But the number of terms I have, so I have 1, 2, 3. So this is actually the first term, second term, third term. So I have 6 terms for this one. And that would give me all 6 of those. So because when I did a to the 6th, that's going to be 1/3, and then 1/3 6 minus 1, which gives me 1/3 times 1/3 to the 5th, which would be 1/3 to the 6th power. So that's a little bit of a tricky thing when you're doing this problem, is making sure that that first one you have the correct starting value. And as you can see, and sometimes in this one, it's a little bit trickier to see that part. The second part is actually really simple. A1 in this case, because it's going to give you basically the formula right there. So A1 is 3, My ratio is -4. And the number of terms I have is 7 because I'm going from 1 to 7. So now we're going to go back to Desmos. And we're going to put those answers in. So I have 1/3, 1/3, and 6. So my first one, so A is 364 over 729. And I just go back here and change this to 3, -4, and 7. And this one comes out to be 9,831. So I can go back to my problem and type those two answers in. And then 9831. All right. This is where learning to count helps. So we're going from k of 1 to k of 7. So if I count that, you get 7 terms, which would be fine. Except when we're looking at this series right here, this is a lot. This is a trickier topic than I originally thought it was doing it. So my first term, when I'm plugging in 1 to this, is 3 times -4 to the first power. But remember, our series is A1 R1. That's not what I have here. So my first number actually in this problem is -12. But that's actually, if I looked at it, that would have been my second term in terms of, because 2 minus 1 would give me the -12. So my first term that I'm going to actually use in this problem is -12. And I'm actually only going, I'm going up 7 because I'm going to do A2, 3, 4, all the way up to the 7th term. So my first term is actually going to be -12 in this problem. If I get it wrong, I start all over. So 157, 284. Nope.
You have to put the comma in there.
No, you did. That wasn't actually my mistake. It was 8. Why was it 8? Now I have to figure out why they had the 8. One, two, three, four, five, 6. That's only 7 terms.
I did one of these yesterday, and I got the answer wrong because the correct answer had a comma in it.
That shouldn't matter, because like in this one, like I actually had the answer wrong. It's the -39,000. It should just tell you that you have to put the comma with large numbers. But I'll go back and look at yours afterwards and just see. But yeah, you shouldn't have to put the comma. All right, so I'm actually going to do this one out because I'm trying to figure out how they got 8. So when k is 1, so this is how we actually work through things sometimes. K is 1, we get negative 12. K2, we get negative 16. 3 times negative 4, 2. So 48. Oh, wait. Hold on. I think I know why. If I did it with the negative 12, which is what I did, this would be 6. Nope. It still has one other term. I'm not sure why it's having that extra term. Let's look. So the first term is negative 12. Which would be n minus 1. Okay, yeah, and you're still doing the 7 terms. That's why it's going up to 7. All right, let's do another one of these. Beauty of live classes. All right, so the first one, so I've got A1 is 5. My ratio is negative 2. And my number of terms in this case is 4. This one, since the first term doesn't have the same number as the ratio, it works out a little bit easier for this one. B, in this case, my A1 is going to be 1/4. My ratio is also going to be 1/4. And my number of terms is 8. So now let's go back to Desmos. 5, negative 2, and 4. And we get negative 25. 1/4, 1/4, and 8. And we get 21,845 over 65,536. My n is 5 for the first one. Because, remember, it's n minus 1. And 4 minus 1 would be not 4. 5 minus 1 would be 4. So my n, the first one, is actually 5, not 4. So it's not 25. It's 55. All right, and the commas didn't matter because it would have yelled at me to put commas in the fraction one too. So, okay, again, I'll go back and look and see what was off in yours. My guess is you messed up one number. And what ends up happening is it looks like you put like it looks like that's the reason why, because you notice the big difference is the comma, and it really was like just off a number, or you reverse two numbers, which is really easy to do. But I will check it for you. All right. Let's try one more since I've gotten one wrong on both of them. Let's do one more. See if I can actually get them right the first time this time. All right, so A1 is 4, my ratio is -3, and my n is 8 because 7 is 8 minus 1. B, my first term is 1/2. My ratio is also 1/2, and the number of terms is 9 in this case. So 4, -3, 8, and we get -6560, 1/2, 1/2, and 9, and we get 511 over 512. -6560 and 511 over 512. Yay. All right, so one other thing when we're looking at this one is, before I do the next problem, which is infinite series, I want you to notice the first one. So notice the first one is the -3, and that number seems to be getting pretty big. When we're multiplying by -3 every time, that number is going to get larger and larger. When we look at the half, now we're at 511 over 512. If I was to take that number again and multiply by another 1/2, it's just going to keep getting closer and closer to a single number. That ratio is the key. So when we're looking at the next one, we're looking at infinite series. So the infinite series, that ratio is my first indication. And notice how there's an answer of no sum in this case. So that ratio, the absolute value of the ratio, has to be less than 1. If it is not less than 1, so basically if that's not between -1 and +1, or what we mostly would consider is like an actual fraction in that case, it's not going to work. Like 2/3 will work, 3/2 won't, because 3/2 is bigger than 1. So you want to make that ratio be less than 1. If it is, then we're going to have an actual answer. If it's not, automatically you can hit no sum. So for example, on this one right here, the second one, I can hit no sum because my ratio is 3. So I know that one's basically going to go off into infinity. There is no sum for that one. Now we're looking to infinity. So we're not actually coming up with a value that's going to give me the answer at infinity. We're looking at what's happening as it gets infinitely close to a value. We're looking for, in essence, the asymptote of it. So my formula for this one, we have the sum equals A1 over 1 minus R. So that's is my formula for this one. So it's actually a pretty simple and straightforward formula. All you need is your initial value and your ratio. So in this case, my second one I know I already have is no sum. So my first one, my A1 is 3, and my ratio is -4/5. So again, we can go back to Desmos, and we can change this formula up here. So it's A1 divided by 1 minus R. And then A1 in this case was 3, and my ratio is -4/5. So my sum in this case is 5/3. So I go back here, and my answer is 5/3. So this formula is actually pretty simple, but the key piece is what the ratio is. Now let's try another one of these. So this one, my first one, my ratio is -5. So I know that's going to be no sum. My next one, my A1 is my first term. So remember, you actually have to figure out your first term for this one. So my first term in this case is -3, and my ratio is -3/4. So we go to my sum. My first term is -3, and my ratio is -3/4. So my sum in this case is -12/7. And that is it. We've now done every single topic that you guys have to do. There's a video for it now. All right.